Hello, my amazing students. This is Mrs. A, and I love math. Today we're looking at lesson 63 in your Saxon Orange Book. We're talking about the product of the square root rule, and later we'll talk about repeating decimals. So, what happens when we have something like the square root of 50 and the square root of 200 and the square root of 147? Is there a way to simplify those radicals down further? And the answer is yes. We can simplify radicals using the product of the square roots rule, which I've written down here for you. If m and n are non-negative real numbers, then the square root of m times the square root of n is the same thing as the square root of m times n put under one radical. And also, the square root of the product m times n is equal to the individual square roots, the square root of m times the square root of n. Now, we're going to use this rule to simplify these radicals. Okay, so this is the first problem. How do we simplify the square root of 50? I'm going to show you how to do this two ways. One, using prime factoring. So we're going to take the square root of 50. Now we remember that 50 divides by 5 and leaves 10, and 10 divides by 5 and leaves 2. So we could rewrite the square root of 50 as the square root of 5 times 5 times 2. Okay, so our product, the square root of the product rule, is going to tell us that now we can write this as individual square roots. And remember that these two, when we square a square root, don't we get the number underneath the radical? So the square of the square root of 5 is 5. So these two multiply together to give us 5 out of the radical, and then we have to tack on the square root of 2. That is one way to simplify using prime factors. But let's talk about 50. Remember, in the last section we memorized, or we're supposed to memorize, all of the perfect squares. And since we know the perfect squares pull out of the radical, we can take 50 and we can split it up using our square root of the product rule. This is a product. One of its factors is a perfect square. Now, I'm not talking about prime factors. I'm talking about splitting it up into its factors where one of them is a perfect square. So 25 is a perfect square, and it is a factor of 50. So now I'm going to have 2, because 2 times 25 is 50, and this is using the rule we just talked about, the square root of the product. Okay, so we can split it up, and once we split it up, then the square root of 25 is just 5, and then we tack on the square root of 2. They're both completely accurate and correct methods. One is using the prime factorization, and another is factoring it into a perfect square and something left over. So if you know your perfect squares, this is actually a faster way to do that, isn't it? So they're both correct. Now this is what your book is teaching you right now. Pretty soon your book's going to go into this one where they may do it a little bit faster, just because this gets kind of tedious after a while. Okay, but right now your book is teaching you this. It will eventually teach you this, but I'm teaching you both at the same time. All right, so here we have the square root of 200. So I've already factored 200 into its primes for you. So it's 2 times 2 times 2 times 5 times 5, which I've written here. But according to our rule, we can split up this product into its individual parts. Now we know from last section that when we square a square root, we get the number underneath the radical. And when we square another square root, we get the number underneath the radical. So 2 times the square root of 2 is left over there times 5. These two are outside the radical and can be multiplied together. So we wind up with 10 square root of 2. Now, we're going to do the square root of 200 the other way. I'm going to split, this was the old answer we just got. I'm going to split 200 into a perfect square times what's left over. Square root of 100 times the square root of 2 is the square root of 200, because we could have just split it up underneath, but our rule tells us that we can break it out into two separate radicals. So now square root of 100 is 10. We tack on the square root of 2, and that's what we got last time. But this time we got it a little bit faster because we used the perfect square instead of having to factor all of that out. All right, so the square root of 147, we're going to first prime factor 147. And I know that a 3 goes into this. How do I know? Because when I add the digits, I get 5 plus 7 is 12. 12 is divisible by 3, and therefore this number is divisible by 3. So I'm going to put in a 3. 3 goes into 14. 4 times with 2 left over, 27. 3 into 27 is 9. Ooh, that is a perfect square, isn't it? But since we're doing it this way, we're going to go ahead and split it up into 3 and 7 and 7. So this is 3 times 7 times 7, which, according to our rule, we can split out into separate radicals. And once we do that, we can see that these two, that's a square of a square root, and that will give me 7, and then this square root of 3 will be added on, so 7 times the square root of 3. We usually don't put the times there in the final answer because we're trying to simplify our radical down. So 7 square root of 3 will leave right there, and then we'll do this using our perfect squares. Okay, on this one, we're going to do the perfect square method. On this one, we don't usually just carry 147 around in our pocket, so we might not know that 49 is a factor. We may have to start doing it using this method. Okay, so then we have 49 is a perfect square. So we're going to break this up into the square root of 49 times the square root of 3, because we know those are the factors. The square root of 49 is 7, and then we tack on the square root of 3, and we get the same answer we had before, but just a little bit faster. Okay, so let's do the square root of 108 two ways. We're going to break up 108 into its factors by prime factorization. I know it has a 2 in it, so that's going to be a 54. I know it's got another 2 in it, and that's going to be a 27. I know it's got another 3 in it, not a 2 in it, right? So a 3, and that's going to be a 9, 3, 3. Okay, so now we're going to write this as the square root of all of these factors. So that's going to be 2 times 2 times 3 times 3 times 3. And then we're going to break it out. Square root of 2 times square root of 2 times square root of 3 times square root of 3 times square root of 3. Now these two go together to make a 2. These two go together to make a 3. 2 times 3 times square root of 3 will be our final answer, or 6 square root of 3. Okay, so now I'm going to go and do it the other way. Okay, so if I'm going to do it the other way, I would notice right away that this is divisible by 3 because 1 plus 8 is 9. 9 is divisible by 3. So if I started out by doing a 3 first in my prime factoring, then that's going to go into there 3 times with an 18 left over. Lo and behold, I find my perfect square. I'm going to break this up into the square root of 36 and the square root of 3. The square root of 36 is 6. I tack on the square root of 3, and there we have it. Now, so right now you're learning the prime factoring method, but when you can graduate to that one, you'll be doing them even faster, won't you? Okay, this last little section is to be memorized. Okay, we're talking about fractions that turn into repeating decimals. So 1/3, when we divide 1 by 3, we get 0.333, and it continues to go on forever. So we just need to remember and memorize that 1/3 is 0.3 repeating. We need to memorize that when we do this division, 2/3 is 0.6 repeating. We need to memorize that 1/9 will always be 0.1 repeating. And we need to memorize that 1/6 will always be 0.1666. The 6 is repeating, so 1/6 is 0.16 with the 6 repeating. Those are 4 fractions that you should memorize. All right, so here is our last little segment. We are doing our practice problems. Practice problem A is the square root of 75, which we can break up into 25 times 3. So the square root of 25 times the square root of 3. And once I break it up like that, that's 5 square root of 3, because the square root of 25 is 5. Okay, so the square root of 200, we already showed you this one, but I'm going to show it to you again the fast way. I break up 200 into the square root of 100 times the square root of 2. The square root of 100 is 10. So we just tack on the square root of 2. I like doing it the fast way. Okay, and then the square root of 189. I don't know this one, so I'm going to take 189, and I'm going to look at it and say, oops, it's divisible by 3, and 3 goes into 18 6 times, and 3 goes into 9 3 times, so 63. And I know to break 63 up into a 7 and a 9, and then a 3 and a 3. So this one I'll go ahead and do with the square root method. So we're going to have 3 times 3 times 3 times 7. So we're going to write this as equal the square root of 3 times 3 times 3 times 7. Okay, so now I know that this right here is a perfect square. Okay, so I could rewrite that as this is 21, right? So this is going to be, let's break that out, the square root of 9 times the square root of 21, because there's no perfect square with these. So that's going to end up being a 3. So the square root of 9 is 3. So the answer to that one is 3 times the square root of 21. And that is simplified. Okay, so because I didn't know the number 189, I had to break it up into 3 times 3 times 3 times 7. But then I saw that I did have one perfect square, so I split it differently into square root of 9 and square root of 21, and that one's simplified. So this last one is just a memorization. What fraction is 0.16 repeating? And that is 1/6, if you have memorized that. And that is the end of lesson 63. And this is Mrs. A, and may God bless your day.